The Java docs define an exception as an event which occurs during the execution of a program that disrupts the normal flow of the program's instructions. Exception handling is used to define what happens when exceptions are encountered while a program is executing. Here's a simple program that divides two integers, then prints the quotient to the console. In this example, the numerator has been initialized to 10 and the denominator has been initialized to 2. When we run the program, 5 is printed to the console since 10 divided by 2 equals 5. However, if we change the denominator to 0 and run the program again, we see exception in thread main, then details on the type of exception that occurred. Here was an arithmetic exception. We tried to divide by 0 to be more specific. And last we see where the exception occurred, which was in the main method of the exception handling class, specifically line 9, where the division operation occurs. We can create an exception handler by putting line 9 in what is called a try block, which looks like this. And try blocks must be followed by a catch block, which will contain a print line statement that says cannot divide by 0. And we will want the print line statement in the catch block to execute should any statements within the try block produce an arithmetic exception. And we will call that arithmetic exception AE. Now when we run the program, cannot divide by 0 is printed to the console because of the exception handler we just created. Now we can make this exception handler to catch multiple various exceptions. For example, let's create an int array called R that will be initialized to contain the values 1, 2, and 3. Then within our try block, we will print out the 10th index of the R array we just initialized. When we run the program, only cannot divide by 0 is printed to the console. That's because we still have the denominator set to 0, and when this line of code is executed, the arithmetic exception is thrown and further execution of the program stops. So for now, let's change the denominator variable here to a value other than 0 and run the program again. Notice now first we get the quotient of 10 divided by 1, which is 10. Then we also see an array index out of bounds exception. This exception is thrown because we tried to access the 10th index of the int array R when it only contains 3 values. So let's create a catch block that executes when this exception is thrown. We can go ahead and add another catch block directly after this one. This block will catch any array index out of bounds exceptions. And should our program encounter this exception, the array index you are requesting does not exist will be printed to the console. Now when we run the program, the array index you are requesting does not exist is printed to the console since we just added this functionality to the exception handler here. At the end of each and every catch block, a finally block can also be added. This finally block will print the string the finally block to the console. Leaving the rest of the code as is, we know that we will get an exception when we run the program. But notice we also see the finally block executed and printed the string the finally block to the console. If we change the index here to 1 so that no exceptions are thrown when we run the program, notice the finally block is still executed. The Java docs point out how the finally block is a perfect place to perform cleanup. What this means is, if any input streams being used to accept input from a keyboard or file stream were open and no longer need to be open, here would be a good place to close them. It is important to point out that if I remove the try-catch blocks, there are no errors, meaning I can change the denominator here to 0 again and still run the program. Yes, we get an exception, but there are no errors, and here the program still compiles. That is because this is a runtime exception. Looking at this program written in the reading text files tutorial, notice throws IO exception here. If we remove this, we get an error on this line of code that reads a file from the file system that reads unhandled exception type file not found exception. File not found exception is a checked exception, meaning it must be handled in order for the code to compile. So one way to handle it is to write throws file not found exception here. Why is this necessary? Well, this constructor accepts a file name as input. Whether the file name is hard-coded here or entered through a user interface, there is a decent possibility the file name is entered incorrectly, and the constructor will not be able to successfully execute. Because of the likeliness this event should occur, Java has required this event to be handled through an exception. One of the ways of doing that is by using throws file not found exception here. So if we remove a couple letters here so this constructor looks for a file that does not exist and we run this program, we see the file not found exception information is printed to the console. We can also use try catch blocks to handle the exception as well, like such.